everyone, and welcome to acadsystems free online lesson. Okay, thank you everyone for joining me. Let's see, thank you Muhammad Sam KAHO. Thank you for joining me today. Alright, first of all, my name is Nur Akila. I am the CAD application engineer here at acadsystems. Before we start, I hope you can hear me clearly and see my share screen. And if you guys have any question, you may leave it on the chat box. Right? So as you joining today's free online lesson, on topic relationship command in Inventor Assembly, you will be able to understand various type of constraint. So what is constraint? Constraint in Inventor means it removes degree of freedom between two selected components, positioning them relative to one another. As you already know, each component has 6 degree of freedom, which 3 moving along x-axis, y-axis, and z-axis, and another 3 rotate along the axis. Okay. Extra degree of freedom are common when using constraint. When you apply constraint or edit relationship to your assembly model, like making 2 components in an assembly, 1 or more degree of freedom is removed. Right. Before that, let me accept participant first. Alright, thank you Faris for joining. Okay, think of assembly constraint as the 3D version of sketch constraint while you designing parts. Like for example, you want to flash 2 components together, or making 2 cylindrical components concentric or even tangent. Okay. First, in constraint, there are various types of constraints such as assembly constraint. They have made, angular, tangent, insert, and symmetry. And also we have motion constraint, rotation constraint, rotation transition. And also we have transitional constraint and constraint set. So without taking too much time on here, let's move on to the Inventor Assembly. Let me open my Inventor first. Before that, let me check if anyone will not enter. All right. Okay. First, I will going over the made constraint. So if you want to access the constraint, you can see under relationship panel, constraint. See, there are under assembly tab, there are 5 types of assembly constraint, which is made, angle, tangent, insert, and also symmetry. So I'm going to show you the made constraint first. What made can do is you can select edges, point, you can select planes to make them together. Okay, each selection we have a different effect, or any selection will depend on your desired result. Okay. Okay, for example, I want to constrain this side to the base. I will use made constraint, and here you can see there are 2 solutions, which is made and flash. For now, I will use made. I want to make the bottom of the side to the base here. Okay. As you can see here, there are offset. If you want to insert offset, you can. For now, I don't want to insert any offset. And also this is for show preview. And this arrow, if you click, it will give you an additional, which you can name your constraint. Let's say, for example, I want to name it as make site to base. This is for example. And also there are limits, which you can also set the limits for your constraint. Okay, for now I click apply. Okay, and then you can see it already made to this surface. And then I want to add more made constraint this to this. Okay, go back to constraint. And then select this as first selection, and then select this as the second selection. When I click apply, okay, the side is already fit into the this, and you can see I can move it because there are one degree of freedom that I don't remove, which is if you want to see, you can go to view and then you can turn on degree of freedom. Then you can see this error, green error, which means that there are degree of freedom have, right? So I want to fully constrain this. And for now, I want to add flash constraint. Okay, I want to use flash this side to this side. Okay, select this first and then select this and click apply. Now, as you can see that my model is fully constrained, so I cannot move it. Also, I want to edit the flash, and let's say I want to add offset to it, 30 centimeter. And you can see the preview that it offset the side to 30 centimeter. Okay, hold on, I want to admit one participant. Also here, let's say I want to set the limit for the flash, and I want to turn on this use offset as resting. What this allow me to do that if I move this to the left, and when I release the mouse, it will go back to the resting position, which the 30 centimeter. Also same goes to when I move it to the right. When I release the mouse, it will move back to the resting position. So let's say I want set 30 and then minimum is 0. I have to set limit. Okay. And then when I move to, this is the minimum for the flash, which are the 0. And when I release the mouse, it will go back to the resting position. Alright. Okay, that is for the make. And then we have angle. Alright. For angle constraint, it allows you to position edges or planar face on two components at a specific angle to define a pivot point. So I have this board with hinge. Apply on it. If you notice that when I move the board, it is freely moved. So I want to insert the angle constraint on it. Okay. So go to relation panel, constraint, and select angle. For angle, there are 3 types, and there are 3 solutions: directed angle, undirected angle, and explicit reference vector. So these 3 have its own function. So let's say I want this board to close like this and to open to 180 degrees like this. Okay, to do that, let me show you the first solution first, how it works, directed angle. Okay, and then source selection, I will select the top of this board here, and the second selection is here. See that the constraint is applied, right? And I click apply and cancel. For angle, I will not insert the angle, right? And then if you notice that if I want to move, the board is not open. I cannot move because the directed angle is only applicable for right hand rules only. Okay, so I don't want that. Let's try the second angle. Let me delete this first. Let me open this. So jump to the next solution, which is the indirect angle. Okay, for the indirect angle, that I will follow the step same as the direct angle. Okay, select the first section and then second section. And then an angle, we'll let it as 0 degrees. And then you can put name if you want to. And then for this time, I want to set the limits. Okay, as you can see, for the direct angle, you cannot set the limit for the solution. So for this solution, I want to set the limits. For maximum, let's say 180 degrees and apply. Let's see. Okay, now that I can move the board, but if you notice that if I release, okay, it will release to 180 degrees. But if I move this board, it means that it still can move freely. All right, that's not what I want. I want this from this. Okay, and then let's try the last solution, which is the explicit reference vector. Okay, for the explicit reference vector, that it will reach the default solution for the angle, and then the solution means we can select the z-axis. As you can see here, they have 3 sections, which is this. The 3 section is the reference vector that we need to choose. Okay, let's go ahead and apply. For the first, okay, I will apply this. I will just repeat the step, this as second, and then for the third selection for reference vector, I will choose this angle 0, and also I want to set the limit, maximum, minimum 180. Okay, okay, apply, and see that now when I try to move backward, it stay on the 180 degree. Okay, this is what I want. So that's how the angle constraint works. Okay, I hope you understand. I hope you're clear about angle constraint. And then we have tangent. Okay, I have this model assembly, and I want to apply tangent constraint on it. Okay, tangent can cause faces, planes, cylinders, sphere, and points to contact at a point of tangency. Like you see, this is a cylinder, and I want to constrain it on this face. So for tangent, there are 2 solutions, which is inside and outside. What inside solution can do is allow to do position the first selected part inside the second selected part. So for the outside, select the first part, outside the second part. Okay, let me show you how. For the first, I will show you the outside, and I want to apply the tangent constraint this to this. Okay, for the first selection, I will select this, and then select this. Again, click apply. If you see that it tangent to the shaft bearing. Okay, if I go to front view, okay, and if go to right view, see it tangent constraint. And also, you can also offset. Okay, right click, edit. You can set the offset if you want to 10, for example, and it will offset 10 centimeter. And for this case, I don't want to offset it. Okay, and then we have inside, which I will apply the inside solution to these two bearing. Okay, select the first, and then select this. Right. Okay, apply, and then repeat. Select this and select this. Apply. Okay, now it's constraint inside the shaft. Okay, for this, if you want to see the inside, you can go to this tangent, edit, and then select this inside, and you can see that the cylinder is constrained inside the box. Okay, that is for the tangent, and then we have insert. Let me open the insert file. Okay. For insert is a combination of face-to-face make constraint between planar faces and make constraint between the axes of the two components. Okay, it's kind of it means that insert is kind of a shortcut for make constraint. Okay, okay. Let's for example that I want. For example, that I can make this to this. Okay, can go to make constraint make, and I can make this to this. Okay, when I click apply, and you can see that it still can move. It means that it's not completely made. So, without wasting my time to constrain it one by one, I will use insert. Okay, use insert. Say I want to insert this to this. Okay, if you notice that there are two solutions which is opposed and aligned. Alright, if you notice, if I hover around this, you can see the axis line pointing up, downward, and okay, select this and then select this whole. Then when I click apply, okay, see. See that it insert to the hole that I can just freely, I can just not wasting my time to make one by one. So by using insert, you can just simply insert it. So let me try to insert this. If I select this and then select this, okay, click apply and it moves. Okay, let me complete the insert constraint for this, for top, and then this. One thing that you notice that it can rotate, and you can lock the rotation. Okay, for you can hover the mouse to the insert constraint like this. For example, I want to lock this rotation. Right click, edit, and then if you can see the small icon for lock rotation, you can activate it and click OK. And now the cap is locked, and I only want this clamping, only want this clamping lever to move. So this is also moved. I will find it. Okay, find the constraint, edit, and turn on the lock rotation. And now only clamping lever can rotate. Right. That is for insert. And lastly, for the assembly type, we have symmetric. Let me open symmetric file. Okay. Here you can see symmetric constraint. What symmetric constraint can do is assembly model where I can move the pad with. Okay. Let's say I want to symmetric this pad to this along with along with the plane. Okay. Go to constraint and click symmetry. Okay. Let's say I want to when I move this pad to the center of the rail, and the third pad will also follow. Okay. Let me show you how. Symmetric. Okay. This first selection, I will select this face and this face as second selection. And then for the third selection, you need to select the symmetric plane, which is this is my plane. And then there are two solutions, oppose and align. For this case, I want to show the oppose first, and then click apply. See, if I move this first pad to the center, the third pad will follow. Alright. Okay, I have another pad on the center. Let's say I want to align these two together. As when I move the third pad to the center, this will follow. Okay. For example, constraint, and for this start I will use align. Oh, sorry. For this start I will use align. Okay, for this first, select this, and then select this as second. For the reference, select this. Click apply. See, if I move this for the clearer view, if I move the third pad to the plane, these two is aligned. Okay. So make sure that if you want to apply symmetry constraint to your assembly, you should have the plane as reference, right? Okay, that is for assembly, and then I will show you how to apply motion constraint on your assembly. Okay, I have this gear. Okay. For motion constraint, it specifies the intended motion between assembly component. Okay, I have this assembly model, and what I want to do is I want to create a constraint between these two cords that show motion on it. For example, when I rotate this small cord, it drives the larger cord, like a gear rotation, for example. So I go back to motion tab, and here you can see there are two types, rotation and transition. For this gear, I will use the first type first, rotation, and then I want to move these two reversely. Okay, select the first, and then select the second. Okay. If you notice that if after I select these two selections, the ratio for rotation is 0.333 UL. It means that once I select the two selection, Inventor will automatically calculate the ratio of rotation for me. Okay, we don't want to use the automatically calculated ratio. You can insert your own ratio if you want to. Okay, for now I will use the ratio that Inventor calculated for me. Right, click apply. Then if you see that now if I move the cork, the large cork will also rotate, but both will rotate reversely. Okay, and then if you notice that this teeth is not fully centered on this area, so I need to constrain it by using make constraint. Alright, let me extend the small cork and the large cork. Okay, to constrain this, I will use plane, XZ plane for small, and then the XZ plane for large. Okay, now you can see that these two cork is aligned and it's centered together. Okay, I click apply. Now if I move, okay, one thing that you notice that right now I cannot move the gear because the mat is unsuppressed. So I need to suppress it. So when I move, you can see that these two gears rotate smoothly and successfully, right? As I move this. Okay, another motion that we have is rotation transition. Okay, on that type, I will show you in here. Okay, I have this file assembly type open. You can see that I can move freely. I don't put any constraint yet. So I want to put motion constraint, which is the rotation transitional constraint. Try on this. Okay, if you notice that for the type rotation, it has ratio of rotational. And for the rotation transition, it has distance. It means that to move this gear along with this rack, I need to specify the distance of rotation. Okay. For example, this is one because I don't select any face yet. So let's apply this as first and then select this as the axis. Okay. As you can see, the Inventor will automatically calculate the distance for me. And for now, for the solution, I will use reverse. Okay, and then click apply. Okay, if I rotate this pinion, if I move this rack, okay, that's how rotation transitional motion constraint works. But if you notice that again, that the teeth is not aligned with this. So to do that, I will apply make constraint for this point to this point. See, it is aligned and then we apply. Okay, same goes to previous example. I need to suppress this make so that if I move, okay, if I move that you can see. Okay, I think I wrongly select the okay, as you can see, I wrongly select. Okay, let me delete and let me repeat. Right, constraint make, select this point, and then select this. Okay, okay. Suppress it. If you don't want to suppress it here, you can click edit, and here as you can see the box for suppress, you can turn on and okay. Okay, as you move the pinion, you can see the motion of rotation transitional. All right. So for motion constraint mostly apply on gear and on rack. Okay. Alright. We have another two constraint, which is transitional and constraint set. But as time goes by, it is already 3:31. So I will show the transitional constraint and constraint set on my next FOL. Fret not that I will stop in this motion constraint for now. And for my next FOL, I will show you the transitional and constraint set. You guys can join, and I will update my FOL for that on our website. All right. So if you guys new here, you can go to our website, acadsystems.com. Okay, this is our website. And if you scroll down, you can see the latest Autodesk promotion and news. All right, and then you can see here, latest Autodesk online lesson, workshop, and webinar. All right, for tomorrow, we have BIM for building, product manufacturer, and fabrication. Okay, if you guys are interested to join this free online lesson, you can click on this flyer and then fill in your RSVP here. Okay. And then if you want to know, you can go to event, calendar event, and then see here all the free online lesson that will be conducted to this month. All right. Okay. And then also you can find us on Facebook and YouTube channel. If you miss this lesson or other previous free lesson, you can watch it in our YouTube channel. You can subscribe to our YouTube channel, and here you can learn freely about various topics in Autodesk product. You can learn by topic here. Okay, we have product design and manufacturing video. We have AEC video also. Right. And then do you guys have any question? You can ask now. All right. If you guys don't have any question to ask, I will end this free online lesson here for now. And then I think that is all for today's free online lesson. Hope to see you guys soon on my next free online lesson. Thank you everyone for joining. Ali, Faris, K, Muhammad. Right. And thank you for now. Bye-bye and Assalamualaikum.